Hi, everyone. Welcome to Between the Brackets. So, my name is Kibra Zengin, and I'm the North America Regional Lead for Google Developer Groups and Women Tech Makers programs at Google. Thank you so much for joining us today. And feel free to introduce yourselves in the chat so we would love to know where you are joining from. So while you are doing that one, I would like to actually kick it off with an introduction to Between the Brackets for the newcomers. Between is a monthly web series where we host experts and Googlers to talk about niche topics on Google products and technologies. So you can check out the website for more information on the schedule on the link and topics specifically. We will cover web, Flutter, Android, Firebase, cloud, and AI ML themes this year. So we are thrilled to have you join us today, and we hope all you enjoy the show. Housekeeping. So as this is a great guideline for all of our events, I would like to remind you all to be excellent to each other. To that extent, please follow all the guidelines, community guidelines on our website and the links we share. So secondly, add your questions to the chat and then be mindful of your questions. We will answer the questions one by one in a timely manner. Hopefully we will cover them all. And then lastly, we are here to help with your any questions. So if you have any concerns, please share with us at btb-team@google.com. All right, today we can just start now. Let's get it started. Today's episode will host two amazing experts on their fields to talk about TensorFlow.js on web frameworks. So you can, again, ask the questions during the show directly. So we will show on the screen and then the speakers can answer the questions, your questions. Now, let me introduce Laurence and Gant are now joining me to talk about JavaScript and TensorFlow.js. So I will just leave the floor to them. Welcome.
Thanks, Kibra. Thank you. So I'll start this off. I just want to say I am a Laurence fanboy, so I just simply accepted this so I could be here with him.
Well, I'm a Gant fanboy. I simply accepted this so I could be here with the Gant chart.
Perfect. That's right. I don't think there's a Laurence chart, so I think that you'll have to keep working on that.
Yeah, I'll get there someday.
So just as a tidbit, actually, I've been following Laurence for a while. He's done courses. I've taken everything that you've had. And also, you lead a bunch of developers who do... now there's a new course out, I believe. There's a TensorFlow.js course out from Jason Mays.
Yeah, so Jason and I put together a course that we wanted to be really around Google AI for anyone. So the specialization is two courses. The first course is me being very high level and being very fluffy. And, it's like, hey, if you're not an engineer, if you're not into software, the AI is still for you. And, so to talk about what AI is and what AI isn't, and to kind of just give people that kind of intro and cut through the hype, because there's a lot of hype out there, let's be honest.
There's a ridiculous amount of hype out there. It's weird.
and AI is a strange one because there's a lot of positive hype and there's also a lot of negative hype. I've never really encountered anything like that in my years. So the idea of the specialization is really to kind of cut through all the hype, to get people beyond the hype curve. Are you familiar with the Gartner hype cycle?
No.
So it begins with this great big peak, and the peak is called the peak of inflated expectations. And then the peak of inflated expectations falls into my favorite part, which is called the trough of disillusionment. And then from the trough of disillusionment, you rise up to the plateau of productivity.
Nice.
But the goal is that all kind of new technologies, anything like that, they always have this big peak of inflated expectations. But you can only begin to do real things once you fall out of the inflated expectations into the trough of disillusionment. And then once you're there, then you can start thinking, okay, now I know what I can do with technology X, like in this case, AI and machine learning, and now I can start being productive. And I always like to tell one story about that. And it's I had a whole bunch of fun working on a project called Stargate AI. And we're actually working on version 2.0. And as the name suggests, it's from the TV show Stargate.
Nice.
And I worked with like the producers and some of the actors to kind of create some models to generate dialogue and to generate scene descriptions and all of that kind of stuff. And then we brought in the cast to reenact their roles by reading through the AI generated scripts. And the peak of inflated expectations there was along the lines of, initially the producers thought, hey, wouldn't it be great if we just get an AI to read all of the Stargate scripts, because there've been over 300 episodes, and have it write an episode? Wouldn't that be awesome? Right? There's inflated expectations right there. And then when it went into the trough of disillusionment, when we have the AI models making up names and making up words, and it came up with some brilliant ones. We had so much fun. Like, there was one word that it made, and it said like one character told another person to get the fakaft out of here. FAKAFT, you know, that kind of stuff. And I don't know where it came up with that, but it's a great word. And another one kind of came up with a word called Graysonians, which, I mean, that sounds kind of cool in sci-fi.
That does sound good.
You know, but it was like, once it, like, the actors were trying to chew these words and get their, like, you know, and they've never seen anything like this. And it was very funny. We had a great time doing it. But that's when we fell into the trough of disillusionment, right? When you realize, oh, this is what you can do. There's all the hype about speculation, but this is what you can do. And then you can rise up and be productive with AI. And like one of the actors, David Hewlett, he played Dr. McKay in the show, if you're a Stargate fan. And he was like, oh, wow. He then began to realize, like, well, me as an actor, when I want to do screen tests, and he's like he's in an Apple TV show at the moment, and he was in Planet of the Apes and other stuff like that. And he shared with me that one of the things as an actor that's very difficult, particularly in sci-fi, is, you know, to go in blind to an audition and they have all the techno babble. Right, you know, you go like and say like, you know, reverse the flux capacitor now, Scotty, you know, something like that, and he was like, to be able to have something generate like tough dialogue like this was actually be something that would help him in his career, you know. So then once he fell into that trough of disillusionment, and then he was able to bring his domain expertise to this, he could start ideating solutions that could be done with AI. You know, so going back to your question, I know I've gone way off the reservation, you know, like way off the trail.
I love it.
But, you know, going back to your question, like that's the kind of thing, the idea with the AI for Anybody course is really all about. So that, you know, people like, in this case, it was an actor came up with a brilliant idea for an AI-based solution. And so my goal with that one was to really get people into the position where now they know what it is and now they know what it isn't, then whatever their domain of expertise is, non-tech, you know, that they might start being able to ideate what you can do with AI. And then Jason, he kind of came in with part two and said, okay, now that like we've kind of created and we've put you in this position where maybe you'll be motivated to learn to do more, JavaScript is one of those things that makes it easy, right, for you to be able to build solutions. And I think there's a book out there about how to do this kind of thing in JS, and it's got like a turtle on the cover, and I see it behind you.
I have one, and also I always keep one at my desk too, just in case. But if you look carefully, you can see Laurence's name as writing the forward. And if you look at the editors, you see Jason. Yeah. So Jason was one of the editors. It was very kind of y'all to go ahead and actually edit the book. This was a lot of fun to write. And if you're looking, then of course we haven't even gotten into why you need to do TensorFlow.js or anything else like that. But at the end of it, yeah, that's definitely the book for it. So Jason has the course for it. So
so that was the vision behind the course. Let's teach people like what AI is for, what you can do with it, even if you're not a developer or a programmer. And then if you do want to dip your toes into the world of programming, that's one of the nice things about JavaScript is that it's so approachable, right? You don't need, you know, high-end computers to be able to work with it, et cetera, et cetera. And so then Jason comes in and, as Jason does, just puts amazing content out there to teach people how to do this.
Hey, he's done a fantastic job with that. And I think that's the JavaScript side is what's really kind of brought it back for a lot of people, because I can tell you, I tried to learn AI back in 2000. It was terrible. Do you remember what it was like? You had like mini-max algorithms and people would talk forever. And you're like, this AI will work for just checkers. And that's it. Now you have to work forever again in order to go ahead and do an AI for chess or for tic-tac-toe or for something else like that. And I was like, I remember sitting through one of those talks and saying, I don't think I want to do AI at all.
So I'll take your 2000 and I'll raise you 1992.
Yeah.
It was my first experience like with AI, and it was really interesting because I was unemployed, and I graduated into the UK, and I had a physics degree and an Irish accent, which is not a good combination in the early 90s in the UK. And I was unemployed for some time, and the British government decided to start this program that they said, hey, look, let's get a cohort of people together who know AI. We'll train them in the latest, greatest things in AI, and it might be a great thing for the future of the economy. And I got to credit them on their foresight. They were probably 20 years too early, but I got to credit them on the foresight. And so they put together, they put this battery of tests, and people applied, and I was accepted, which was really cool. But then when they started teaching us AI, they were teaching us languages like Prolog and Lisp. Do you remember them?
Lisp is still around. You still got people who love Lisp. Can't get rid of it.
And they've worn out the bracket keys on their keyboard, right? Because it's just everything is bracket, and left,
Yeah.
But the extent of what we were doing was like, inference, like in Prolog, was like, you could say, I remember my hello world in Prolog was like, likes John Mary, likes Mary food, and then inference is, can you see if likes John food? That kind of thing. And it was like, and then like the inference engine would kind of come up and give you an answer to that. I remember we were learning all of this, and then we went to industry and presented that. And we were laughed out of the room, right? It's like, how am I going to use that in banking? How am I going to use that in, the conservation or any of the other big industries? And so yeah, it kind of failed.
Well, I mean, I think that's okay. For a while, it was just super impressive. I have no idea how any of this happened, but AI was mostly, it was, a lot of times it was people coding the AI.
Yeah.
And I feel like, the resurgence now, the exciting part of like why AI is so interesting is we're overflowing with data, and I think that makes everything a lot easier. I've made a lot of really fun things with a small amount of data, and it's exciting. Yeah.
I think it's really a combination of three things, and like there's three trends all intersected at the same time. Number one is data, as you mentioned.
Yeah.
And number two is compute power.
Yes.
Right? Moore's law is still very much in effect, and if anything, it's accelerating. And then number three, of course, is like high level APIs and connectivity that allows like open source to be shared.
Yes. That's a good call.
Way back in 1992, like when I was talking about, it's like you'd had to buy Prolog on about 50 floppy disks at a cost of about $300, that kind of thing. And it was like, you had to really want the thing. But now, like, Python, for example, is open source. And I don't know if JavaScript's open source, but freely available open source tools for you to be able to program with it and all of that kind of stuff. And it's those intersections of those three things has just certainly made it like, feasible and possible and kind of easy. I'm sounding like one of those guys. Like I used to have to walk uphill both ways.
I had people shooting at me, and I didn't complain.
but it is true that it's much easier. But like, of course, then the demands are also much heavier. Like if you were able to do inference that determines if John does like food, going back to my problem, that was amazing. But now if you do that, like that's not good enough. So the demands are much heavier now as well.
I know. There's just an XKCD not that long ago where they have this joke. We need to identify if there's a bird in the photo. Oh, that'll take me 5 years in a research team. And what's funny is like now in courses that could be, lesson 1, is there a bird in this photo? And I think that's what's kind of, for me, that tingled my sort of my opening into this. I'll say that seeing shows like Silicon Valley have Hot Dog, Not Hot Dog, and it's a real program that they actually released and that you can download, and that was a real thing. I was like, how are you coding this? Yeah. And they were like, yeah, we did this. They released a blog article about it. I think even the source code was available for a while. But I think that's a big issue for, you and I, we work with people who are coding. So Laurence, you're there pushing forward the amazing things at Google. I'm over on the consulting side with a lot of people coming in with mobile apps at Infinite Red. So when we're dealing with the people coming in and asking for things, I'm starting to see it kind of creep up a little bit. Like, oh, we want to recognize these faces. Oh, we want you to go ahead and scan barcodes and identify if this is a picture of an ID and stuff like that. And people are starting to kind of get the idea there.
Right. So I think they've fallen into the trough of disillusionment, and they're beginning to climb
I hope
up and
so.
rise up through the plateau of productivity to get back
Yeah.
to the hype cycle. And it's, which is a great thing,
Yeah.
because, and then prior to that, if everybody's like, AI is some kind of magic pixie dust that suddenly is going to make my startup unicorn, or, that type of thing is like really what I want to smash through. And I'm beginning to see it happen as well, which I find is, that's the most exciting part of it.
Well, I registered Trough of Disillusionment on Twitter, so don't anybody try. It's mine now.
So if you're a Stargate fan, when we were doing the whole Stargate AI thing, there's a group of bad guys in Stargate called the Ori, and I suggested that the Trough of Disillusionment sounds like an Ori holiday camp, and everybody agreed. So at some point, if there is a future show and the Ori turn up, we're going to work that joke into it somehow. So.
I love it. That's perfect. Yeah, there's too many great sci-fi shows. I actually did a sci-fi project where you would you would draw on the screen in TensorFlow for JavaScript, and it would identify whether or not you are in a particular Hogwarts house. But
Okay.
then I did like this additional transfer learning on top of it. I know poor people are just trying to be like, why is he using these terms we haven't defined yet? But what happens is if you draw Star Trek symbols, it tells you which Star Trek symbol that you drew directly in there.
Nice.
So it's pretty, which is very useful for, I don't know what yet, but as we're coming up out of the trough, I'm sure people will need to identify different cool symbols.
Yeah,
So.
exactly. Well, I mean, I can see something there where to train somebody for different gestures for like controlling the UI, instead of me dictating that swipe this way for a left, swipe that way for right, people of different abilities might want to use gestures in different ways. So like, maybe this is left and this is right, or something along those lines. And the ability to train that is part of the goal here, is widening access to everybody. And I think that with traditional programming, scenarios like that are very, very narrow. But with AI, like, and with being able to train something in the browser, I think that's really cool.
Yeah, absolutely. So I think we're going to, apparently I've got a little message here that says that we're getting some questions, but I want to get to the questions, but let's you and me talk about what AI is, and like at least get people to what TensorFlow is and TensorFlow.js. So we've kind of talked a bit about the data-driven AI as far as getting there. And I guess we can define all this as these simple tasks as narrow AI. And you remember writing all these writing all these things from scratch. So I guess we'll start from there. People kind of get the idea of what AI can do. We're starting to see it in apps. It's obviously not the super intelligence. It's not Skynet. So from there on, I guess people first question is saying, okay, I've kind of got this generalized idea of AI is, what's TensorFlow?
Great question. So I like to think of like TensorFlow as part of a bigger ecosystem, but it's part of that ecosystem. So if you're trying to build any kind of AI solution, there's generally 4 big things that you need to do. One of them is gathering your data, preparing, pre-processing your data, all of that fun stuff. The next one is defining your model architecture and training the model with that architecture, and like making sure your training works well. The third one is then deploying it and to a variety of surfaces. And then the fourth one is like managing and monitoring the deployment. So I like to see TensorFlow as like touching all 4 of these.
Yeah.
Right. A lot of times we tend to think of it just the model creation and training, like with things like Keras or, defining layers and that stuff. But, I always like to say, like, first of all, when it comes to your code, those first 2 things, like if you're writing this much code, this much of it is the model and this much of it is like your data preparation and cleansing and all that kind of thing. So, so whether you're pulling data from like one of the sources that we make available through 2 or 3 lines of code in TFDS, or whether you're bringing your own data, you still need all of those APIs to manage it. There's all the S's, right? It's sorting, splitting, slicing, and sharding. Those kind of things all need to be done. And that's a lot of code is often involved in that before you even think about AI and models. And so TensorFlow does that. Then, of course, there's the model definition, that kind of thing, and training and monitoring. TensorFlow does that. And there's a thing called TensorBoard for monitoring while you're training.
Yes.
Then there's deployment. All right. So you can deploy to the cloud, to the web, to the browser, to the mobile device, to the embedded system, or to the microcontroller. The browser is probably what we'll be focusing on here. So where you can take your trained models, deploy them to the browser, and then run inference on them using JavaScript. And, which is kind of magical when you think about it, right?
It is by far. Just JavaScript actually being able to keep up or be in that same ballpark is wild.
I just like all of this supercomputery or developer stationy stuff to create the model, and then like flatten that model, optimize it, deploy it to a browser, and then anybody can run inference on it. So for example, people can draw their Star Trek logo, or people can draw, here's how I gesture left, right, up, and down, and those kind of things in the browser where it's really accessible. There's no deployment, well, there is a deployment of the model, but you don't have to install stuff to be able to get it to work. And so to me, that's what TensorFlow is. It's like, it's the tools, the APIs, and the surface that allows you to touch all of these columns.
Yeah, that's a fantastic answer. There's a reason, you know what? There's a reason why they hired you. That was the best TensorFlow answer I've ever heard. And the part that's really exciting to me, so building apps in JavaScript all the time, building mobile apps in JavaScript, the idea of taking this AI infrastructure and bringing it in on client device and putting it on websites is the most exciting part, because there's a really cool websites out there that are saying like, oh, check this out, we'll run this cool AI thing for you. Sorry, our Python server is bogged down. Come back in an hour. We can't wait to show you what you look like as a cartoon or something like that. And now these things are being pushed over into the end devices, clients and mobile devices, and the loop from here to the process and the inference back to the user being on client devices is instantaneous, and in some of the models happening at like 100 frames per second. So instead of waiting for your line in a queue, your machine's just chugging away, accessing your GPU in JavaScript to give you direct access to exactly what's happening.
I mean, it's the ultimate in distributed computing, right?
Yes,
being able to take an intelligent model, deploy it to the metal on your machine, use your local GPU for inference to speed it up. All of those kind of things is great. I mean, there's still a place, to be fair, though, for hosted models. I mean, some models are too big to push. Some models need like something to be centralized and
secret sauce.
Exactly, all that kind of stuff. But but options are always good. Right. So you don't want to be like, hey, you can only solve this using AI if you run it in the cloud, or hey, you can only solve this if you run it in the browser. That's part of the passion that I have, and something that I've been kind of driving is as many deployment surfaces as possible, from the cloud all the way down to the microcontroller, and work with the best of what you can do in each of those.
Yeah. And then of course, if it can be written in JavaScript, it will be written in JavaScript, the famous quote. So it had to end up there eventually.
I once went on stage and I was introducing TensorFlow.js in a conference, and I said, like, to the group that I was talking to, was like, JavaScript is the world's most popular programming language, and there were a few boos. And then I was like, I never said it's the world's most beloved programming, but it's the most popular one for a reason, right? That,
yes, absolutely.
You can use it everywhere. It's being able to deploy stuff to it. The browser is the ultimate deployment surface for many, many types of applications. And when you can run things without an install and without like DLL hell, if you remember that thing.
Oh my goodness, yes.
That to me makes it really, really special.
Packaging things up with the Visual Basic runtime.
VB Run 300 DLL has failed.
Oh yeah, everybody's like, what was it like to program a while ago? Just know that, hey kids, you've got it easy now, okay?
Exactly.
All right, well, they sent the message that we're getting some questions, so let's take a look at what kind of questions we're getting. Oh, I'll read it. Gant and Laurence, is there a place where students can learn about TensorFlow.js doing hands-on labs? Thanks in advance. I'll let you go ahead and start that one.
Okay. I mean, so I think codelabs.google.com has a bunch of various TensorFlow code labs, including some that Jason put together for TensorFlow.js. I know at the very least, there's one really cool scenario that we worked on together for comment spam detection, where using TensorFlow.js, you can train a model on a data set of comment spam. And just going back to what we were talking about earlier on, this is one of the magical things about JS is not just the initial deployment, but redeployment is easy. So the idea with this one is you train it on comment spam, you put your model out there on comment spam, you can run it in glitch, which makes life really easy. And then guess what? People will always find ways around your common spam engine. So Jason's Code Lab will then take you through, okay, here's some extra training data to train a new model and redeploy that and see how easy it is for you to be able to do that. So that one for sure is on codelabs.google.com. I think the edX course that we mentioned earlier on, the Google AI for Anyone, I know Jason has been working so hard on that he's got a ton of stuff there that I would take a look at that. And I'm pretty sure, Gant, you've got a lot of resources that support your book.
I have a ridiculous number of resources for you to check out. And I just want to say kudos to that comment spam. I'm actually using that to go ahead and work into a Slack bot that's going to identify when a sales lead is spam or not. So
nice.
We have a contact form where people bring in work to us, and about 50 to 60% of the people who fill out that form are just basically trying to sell us services rather than let us sell them services. So we have a history of all those comments and whether they're spam or not. So I was like, hey, this is a great opportunity. I can take that, custom train it, and then actually have it set up. So super cool. And it could work directly into Slack so we can get those emails, because JavaScript. So
we found something positive to do with all of those spams that keep bombarding our blogs.
Yes, yeah, exactly. And we can share this with other consultancies as well. Thank you, spammers. Yeah, as of right now, we have a human spam detection system. Everybody sees it and then clicks on a little link on whether it's spam or not. But we could take that up a notch. And then also I'll say for me, there's two links that I have that I would say that are really great. One for me was just watching something learn how to get smarter as data kind of comes in. So I created this project called TensorFlow tic-tac-toe.co. It had to rhyme. The .com was available.
You have a future as a rapper.
TensorFlow tic-tac-toe.co. And what I really like about this is it's a tic-tac-toe AI bot that starts off completely untrained, and you play a game against it, and then you say, okay, learn to play more like X or learn to play more like O, and then it trains, and then you play it again, and it makes a new mistake instead of the last mistake, and then you click train again, and it's training all in your browser. So after 7, 8 games, it becomes just as good as you because you've run out of places to make mistakes. So you can actually watch it right there. And that's a good hands-on no coding example for you to get a taste of sort of how that works. Now, if you're looking for a coding example, I actually have a rock, paper, scissors trainer. And that's using a data set that you released, Laurence. The rock, paper, scissors data set. Yep. And it shows you all the code, and it starts off the same way. It doesn't know what's going on. You ask it, is this rock, paper, scissors? It's like, I don't know. It shows you the bias in TF-Viz. And then what happens is you go ahead and say, okay, load the data set, train it, and then get set there. And that one's at, let's see, I have it, rps-tfjs.netlify.app.
But that doesn't rhyme.
That one doesn't rhyme. This was earlier in my marketing there. I didn't get a good one. So that's rock, paper, scissors with your data set. It's learning directly in the browser. So if you say show code, it shows you the code. And you click button, it runs that code. And then you're basically kind of going through what a lot of people are used to, sort of like just feeding it through the website. And then it opens a panel on the side. That's two really good, I think, intros with watching code rather than actually coding.
Very cool.
Yeah.
I'll have to check.
All right. Well, I think we could get another question in.
Sure.
Speaking of computer power, I find it amazing that TensorFlow Lite can run on a Raspberry Pi Pico. What do you think the floor will be for edge computing? Ooh.
That's a great question.
That is.
I don't know. I to be honest, I don't think you can define the floor too low. Right. Just when you start seeing that, like, if I can't start doing it along the terms of the floor being based on price as opposed to based on power, that the amount of power that you get per price is like, you've got that beautiful curve heading in your direction that, something like a Raspberry Pi Pico, that equivalent compute power 20 years ago would have been like 2 months salary. And maybe 2 years' salary. So as compute price is going down, which means the power per dollar goes up, that means, to me, that's raising the floor. And so I think, as cheap computing becomes more powerful, then the ability to run an inference engine on that, like a TensorFlow Lite or even a TensorFlow.js, becomes much more and more feasible, and the amount of functionality that it supports becomes more and more, it becomes broader. So I think, if I draw the floor, not in terms of, teraflops or anything like that, or capabilities, but in terms of price, think about like what the $1 computer 10 years from now is going to be able to do.
Right.
And that to me is when the floor gets really, really exciting.
Yeah, that's such a great point, because the hardware is not done. The hardware is just not done. So the floor is still coming down, because we're using GPUs because it just so happens that they're fantastic at linear algebra. However, there's been this entire new vein of hardware that's AI specific, AI centric, low power AI stuff that can work off of a solar panel. And this allows you to take, I think I've heard of people looking for identifying poachers out, and so they're able to put solar paneled cameras out and what happens is it can access a card and do a call or a message whenever a person's identified or the wrong things are identified in a particular area. And it's just amazing to me, because that's essentially a person who doesn't sleep sitting there watching for that one thing all the time at a cost of $0 is solar powered.
Yeah.
It's amazing to me. And like, we're not even starting to really crack that.
Yeah. And in a similar vein, those kind of things can also be done with audio, because then you don't need line of sight, right? So things like poachers for illegal logging, there are solutions out there already that all it has to do is hear a chainsaw. And if you have enough of these around and they hear chainsaws, and then you can triangulate them, then you know where the illegal logging is happening. So it's that type of thing being driven by low cost as opposed to increased functionality, I think is where I start looking for the floor. Because if you can build a device like that 3 years from now for $1, right, and the solar panel is another $3, and it can run an audio-based model, and it has the microphone on it, then you can put 1,000 of these in a forest, and the cost is minimal, and they'll dial home, over Wi-Fi or wireless or something like that, and it's easy to triangulate once you have 3 or 4 of these, like hearing something that it doesn't want to hear, and then solutions again fall into that trough of disillusionment, and then think of the kind of solutions that you and I, we're not experts in this area. We can build the technology, we can build the code, but there are people out there who are experts in conservation. There are people out there who are experts in, I don't know, food production or any of these kind of things, that once they start seeing the possibilities with these, it's and the cost being low, then that low floor gets really exciting.
That's the most beautiful part for AI for me, has been that it's been directly applied outside of my nerdy world. I am a full-on nerd, been for a while. Obviously, you have too. But people are taking it and they're immediately applying it to medical science or logging, or there's so many different things that it's just the ideas are specific to those domains. And they're like, oh, well, we can't, pay a person to sit there and stare at 18 monitors to look for a gun, that's a lot of effort and time. They fall asleep or this or that. And then also the cost of that person is extremely high. And then someone comes along and says, this is a real problem over in this apartment complexes. And so you're telling me AI can do that? And then when they say, yeah. Oh, I didn't know that was a problem. And then next thing you know, it's just reapplication of the same sort of amazing paradigms of finding a bird in a photo, but now you're finding something else in a photo. And then there's someone's like, I've been waiting for this. And that's the most beautiful part.
And then there's the things that it opens up that nobody previously thought of because it was infeasible. Like there's one great story. I saw a documentary about a year ago about a company in the UK that iceberg lettuce, right, that goes through a craze, like in the UK, usually in the month of June, like people are watching tennis, they want to have salad, all this kind of stuff. So there's intense pressure on stores to have the freshest iceberg lettuce in store. But once you cut it, it begins to die. And if it's not super crisp and fresh, people aren't going to buy it. But in order for stores to have enough to meet demand, they have to waste a lot of food. And so there's this company, what they did was that they built a drone that can fly above the field And then it can, using an image classifier on the drone, it can spot exactly where the freshest lettuce is now. So they can harvest it, they can wrap it, and they can get it into the store on the same day. And they don't have to waste nearly as much as previously, because in the past it was like, let's cut from this part of the field, right? Maybe some of them are fresh and some of them are overripe and some of them aren't ripe enough yet. So a lot of that sells, a lot of that doesn't sell. And a significant percentage of it gets wasted. And we're living in a world where it's like, if we can use technology to avoid waste like that, and think about the environmental impact of the food being grown and all the water being used and fertilizers, and then the food's just thrown away, that kind of stuff, that there's like, lots of like efficiencies that we can drive like that with solutions that nobody ever thought of. And so it's being able to do that type of thing, I get really, really excited to see.
That's amazing. I registered lettuce drone on Twitter, so that's taken now. You can't have it. I'm just listening and slowly taking all the best Twitter names ever. Lettuce drones. I did not see that one coming. It's beautiful.
Yeah, I'm sure it's applied to any kind of food production, not just lettuce, right?
Yeah.
Just think of, you always hear about supermarkets and like how much food they throw away, and then sometimes it's donated to homeless shelters or things like that. But then you often see like these stories of like these great big bins at the back, which are just full of food because it's past its expiry date.
Yeah.
It's still perfectly good, but it's past its expiry date. But if you can make that supply line much more efficient, using predictive technology as well as lettuce drones, that kind of, then some of those kind of problems can be greatly reduced, and it can be done at a cheaper price. So it can be driven by market forces as well as social forces, and it's all of these kind of things that we're just really on the cusp of seeing now, and the next 10 years I think are going to be super exciting in that regard.
Well, definitely, because as creative as we are, there's a lot of very, very, very creative people out there that just sort of don't understand the technology and what it can do yet.
Yep.
And they're the people who are going to really set this off. I think that's where it's going to get very interesting. Maps was released for a while, and I know it's weird to make AI analogous to maps, because maps are sort of like single focus. AI is very broad on that. But for the human mind, it's very difficult to sort of think of all the things. Now, if you could go back in 2008 and say, okay, here's all the apps that are going to like take off, here's what people can think of, here's what we can do, here's what's going on. What's funny about that is it was just, the technology was all around. It was just the ideas coming out and people implementing them and building multi-million-dollar, billion-dollar businesses on top of those ideas. And I think like this is the sort of the same time where you have the technology, but people haven't figured out how to use it yet.
Yeah. Well, just going back to 2008, like you said, I mean, it was common wisdom at the time that you don't talk to strangers on the internet and you don't get into strangers' cars. And then after the revolution, we now literally summon strangers from the internet so we can get into their car. And that's safer than standing on a street corner, raising your hands or putting your thumb like to hitchhike, that type of stuff. So it's like they did drive change in the world in that way, which is and hopefully in a lot of way. And there's always going to be like some steps forward, some steps back. But I think overall, there's always a net gain. And a lot of people tend to focus on the negatives, and it's good to understand and to analyze and to realize the negatives so that you can, those who don't learn from history are condemned to repeat it. But an overdue focus on the negatives can sometimes hold us back. And there's so many positives out there, and they're not hype, they're not marketing. There's real positive things happening.
It's superpowers that we're getting, and any superpower can be used for good or bad. Right.
Yeah.
The hope is that it's in the right hands, and we work together, and democratized AI hopefully drives us forward in a way that everybody can kind of accept. I know that there's a lot of, whenever a car is making a decision, it's taking a decision away from a person. Even right now, people get very, very, very hyped up about that. And it is a sticky point, and I do appreciate when people are taking their time to think about it both. You can't ever have an AI discussion without talking about ethics. So that drives into almost every single discussion all the time. And I honestly believe that, we're doing pretty well with it, but people are rightfully scared. Laurence, you said something once that I think was really great. Why are people tell everybody why are people scared of AI? I think you said something about
Can't remember.
you said something about like we're driven so much from science fiction.
Oh yeah,
It's
I
so
mean,
true, you know, because
yeah, definitely. It's like, you know, the narrative. When I talk about the peak of inflated expectations, that there's the positive peak where people think AI is some kind of magic pixie dust that will solve all our problems, but there's also the negative from that, and an AI in particular around that. Because I mean, when you go all the way back to the first science fiction, like sometimes people think it's Mary Shelley's Frankenstein, right? And if you think about it, that's an AI, right? It's an artificially intelligent being.
Yeah.
And things go wrong, and you know, and it's part of the I go back to the Stargate thing because I'm having so much fun with it, but that's part of the dialogue I had with the creators around that one of the frustrations that I have with science fiction is that, you know, when you create a story, you need an antagonist. And you know, it's, you know, once upon a time, you know, you look at stories that were written in the 1400s, 1500s, the antagonists were humans from another part of the world. But now we've become more global in nature, you know, and it becomes really weird to have like, you know, this racial group or this ethnic group be antagonists because that's racist. And, you know, hopefully we've risen, or we're trying to rise above that. So science fiction then turns to other places for antagonists, and it's usually aliens, but we kind of get a little bit tired of aliens, you know. And then it's like, and then the common theme is around AI as an antagonist. And like, you just look at almost any story that has an AI in it, they are the antagonist. And it's, you know, and I kind of think someday we will look back on those stories the way we look back on stories today where, you know, particular racial groups were the antagonists and they were caricatures and they were completely wrong, you know, but they had to be reduced to caricature to make them an antagonist. And we've inherited part of the problem of that today because sometimes those groups are still treated like the caricature that they were in these stories. And that's wrong. So it's like, we're kind of bound by that a little bit with AI. Like, I love sci-fi, as you can probably tell. I watch just about everything, you know, that there is. And I mean, I was joking. I think when I made that comment, there were 2 Star Trek shows on TV at the same time, and it was and it was Discovery season 2 and Picard season 1.
Yeah.
And both of those, the main antagonists were AIs, you know, that kind of stuff. Like, come on, guys, come up with something new. You know, there's so many stories you can do. Come up with something original. And you know, and that has kind of put us into the area that the average layperson who watches these kind of shows or who's consuming that kind of media can be fearful. In the same way as they were fearful of the other, you know, when it's talking of other types of humans historically. And I think, you know, we should learn from history to avoid those mistakes. So creators, I've been giving them that challenge to come up with something new and to come up with something exciting, and let's see what happens.
Yeah, you know, technology advancing messes up storylines all the time, and they have to, you can't have a horror movie anymore because everybody has an internet connection. So every horror movie has to start with, "I don't have connectivity. What's happening here?" And then like, okay, whenever I don't have connectivity, I know I'm in a horror movie. So I'm like,
exactly. You know, if you find yourself in the woods and there's a mysterious cabin and you've lost connectivity,
y'all want to read from this old book?
You know, don't run into the garage full of chainsaws.
Right. Chainsaw detection. There you go.
There you go. You know.
Awesome. All right. Well, I think we have another question, by the way. So, hi, Gant and Laurence. What is the future for TensorFlow.js? Can explainable AI play a role in improving TensorFlow.js? Ooh, that's good. Laurence, do you want to give everybody a premise of what explainable AI is?
Yeah, so the idea of explainable AI is so that sometimes, like if a model comes up with an inference, that there's a way that you can audit why it came up with that inference. And so, for example, with graphical models, if it's classified, to use the chainsaw example that Grant just gave us, is like, you know, if you show a picture and it's like full of chainsaws and it's this is a chainsaw and this is a chainsaw and this is a guy wearing a hockey mask, you know, then the idea is that like, why did it like go to those particular pixels to say that it's a chainsaw.
Yeah.
And there's types of models that you can use to kind of almost do like a backwards inference through the model, so you can see why it did that. So being able to explain that and interpret that is very, very important. And that's really the idea behind explainable AI. Can I tell a story about that, actually?
Please,
I don't know if we have time. So one of my favorite stories that really labels the point about this, I don't know if it's true, but it's one that I read, and I hope it's true. And it was from years ago that the U.S. Army engaged with a group of, you know the one, right?
I know the story. It's a great one.
You know, and they engaged with like a group of people to see if they could build a classifier to determine a camouflaged tank. And, you know, to look at images in camouflage tanks. So they got a bunch of researchers, and then these researchers, they gave them a tank. How much fun would that be, right? You know, and to go and take a whole bunch of photographs of this tank one day, and then on another day, they gave them a camouflage net that goes over the tank, and they drive it around the woods and take a bunch of photographs of that. And then they used all this data to train a model, and then they trained the model, and they looked at the accuracy numbers coming out of the model. You know, you split your data into training, test, validation, and they looked at the validation numbers, and it looked really, really, really good.
Yeah.
So they brought it back to the generals or whomever it was that commissioned it, and you know, these folks were like, "Oh, this is amazing! This could change the future." And so then they put it out in the field, and it failed miserably. And the reason why it failed miserably, and it took a lot, this was before explainable AI techniques were out there, that it took one bright-eyed guy to take a look at the data and realize that the day that they took the pictures of the tank without the camouflage net was sunny, and the day with the camouflage net was cloudy. So instead of building a tank camouflage detector, they built a cloudy sky detector instead. I hope it's true, because it's such a great story.
I know, it's such a great story.
and that's the idea behind explainable AI. So it's like, you know, if you could, there are algorithms out there now where you can kind of audit what your model is doing. And I do it in one of my Coursera courses where I take the user through that, and the famous cats versus dogs data set, where they'll train that to do a cats versus dogs classifier, and then they run it through a UNet to do the explainable AI part of it. And it turns out what was really interesting is that for all of the theory that we talk about, like, you know, features and feature extraction and that kind of thing, it actually just zeroed down on the eyes. And, you know, this one particular model, it was like a Keras model that we built that was very accurate at determining the difference between a cat and a dog, that when you do it, there's a thing called the salience map that it will draw on top of it. And the salience map just basically draws on the eyes the whole time. That says, like, if you want to tell the difference between a cat and a dog, it's the eyes. You know, so it's, and that's the idea behind explainable AI. Now, the second part of the question, can this be used to improve TensorFlow.js? I mean, I don't know about improving the framework as a whole, but I think you can definitely improve the type of applications you built with it, and you can increase people's trust in those applications by having explainability built in.
Yeah, I can tell a really weird story coming in. So I have a project that's extremely successful, but it depends on who wants to talk about it. I have requests to speak at it at conferences all over the place, and I kind of have to zero in. But there's a library I did for community in TensorFlow.js, which is indecent content checking. And the reason I wanted to catch that is because I wanted to make sure that there's something free out there that small groups can do. So if you're running a conference and somebody sends a photo to someone else, it could say, warning, do you sure you want to see this photo? We're 90% sure you don't.
Right.
You don't want to see this photo. So that made me make nsfwjs.com. And what's great about that is people constantly are reporting back on it. And there's one person who reported a ridiculous false positive constantly. And so there's this false positive with NSFW.js. And I was like, I don't know why, but apparently anybody who's drinking tea has this through the roof rating of being indecent. It is, you cannot drink tea. And I was like, I don't know what's going on here. And this is where, you know, I'll definitely say explainability would have been wonderful. So did the backtracking through the subreddits that went ahead and were actually used to train the model on this, because subreddits are human categorized on this. And apparently there's just a subreddit out there for indecent photos of people drinking tea. And that was in the set. It was not counterbalanced. So now anybody who's drinking tea And so it was very hard to figure that out. I think explainable AI would be fantastic. But yeah, if you're just sitting there and everything's fine, and then you start drinking tea, the detector was going off. And this is how it works with open source. It's just one of those things where the community, and there's tons of servers and Discord servers, and like I said, there's definitely bias in the model. I don't know how to find out or check into those kinds of things, but I think explainable AI, as it sort of becomes more of a staple, will really help out, not so much directly in TensorFlow.js, but in the actual training and the process and explaining, and then the models go out and are implemented in end products with TensorFlow.js and TensorFlow Lite and just general TensorFlow.
And you could perhaps deploy an explainability model as well, so that if people have false positives, that they could run it through that and they could see why. And it's like, put down the teacup. And I'm just envisaging a future episode of Star Trek where Picard goes tea, Earl Grey hot, and the replicator goes, "Are you sure you want to do that?"
Yeah, are you sure? Earl Grey hot. That's right. Yeah. And then the replicator's like, "No, sorry, buddy.
Gant says you can't do that. Sorry."
Yeah. Some guy back in 2022 went ahead and made a model that says no go.
So but now I know I will stick with coffee.
Exactly. Yeah, it's just there's so many different great applications on this, but I do think explainability is going to really help out with model bias. Any data that's collected, and this is really important for I'll say if coders that come into this, one of the things that I see that they really get bothered by is they don't have a Boolean life answer. They see they're used to is it cloudy today, or a tank detector, depending on which one it is. Yeah. They want to see yes or no. Right. But what's funny is it's all working inside of math, so it's probabilities. So it tells you, oh, we're 95% sure there's a tank there, or yeah, we're this sure on one thing or another, and then we have to kind of come back and continue to augment the data, sort of like Jason has in a spam detector.
Right. Yeah, and I mean, and then when you go beyond 2 or 3 things like that, so for example, if it's an image classifier that can recognize 1,000 different types of bird, it's going to give you an answer for all 1,000. And say it's 0.999% sure it's a crow and 0.001% sure it's a hummingbird, that type of thing. And to be able to deal with that in thresholds it becomes a change of mindset when you're developing.
Right. Yeah, absolutely. I want the AI to be 100% sure. I'm so sure.
The funny thing is, though, that doesn't that make you suspicious that there's a bug when it comes back and says it's 100% sure?
It's like writing code and having it run on the first try.
Yeah, I'm definitely suspicious if nothing goes wrong and no warnings and no errors, and it's like, I showed a picture of a cat and it says 100% it's a cat, something's wrong.
You just block the eyes out and see if it still knows.
Yeah, that'll be good.
That's perfect. I think there's another question Madhusha's saying here. So my simple question is JavaScript enough for ML and AI, or need to learn another language?
We may have varying opinions on this one. I think JavaScript is absolutely enough to get started. And I think I'll talk about remember I talked about the 4 columns earlier on, but in one of those columns is really training. And so when it comes to training your model, you can do that in TensorFlow.js. You can train within the browser in JS. But often, if you're dealing with large models, lots of data, billions of records, those kind of things, that you're probably not going to be training in the browser. And as a result, you'll want to train on either a developer station or we have something called Google Colab that lets you within the browser do the training, but the actual stuff is being done on the back-end machine. And those all use Python. So I would say definitely it's enough for you to dip your toe in the water and maybe meet 80% of what you want to do if I follow the 80-20 rule. But when you want to go a little bit further and when you want to kind of start exploring other scenarios, that I definitely recommend Python as well.
Yeah, I agree wholeheartedly with that. I would love to see just JavaScript be the full option. And so what's funny enough is in my book, the whole thing is all the training, all the transfer learning, all that stuff is all in JavaScript. But the support for JavaScript is so new compared to the data science world, forever pushing inside of AI and Python. So you are trading a little bit of what's been built up over years and years and years, perfect libraries that have been tested, that are deploying things all over the place, that you can rely on, for a bit more of the bad scientist experimental if you're staying just in JavaScript.
Yep, agreed. But I mean, people can have a perfectly valid career, build perfectly valid stuff, and never leave the JavaScript world.
Yes. Yeah, absolutely. And I think that that's the future of it, is definitely going to go a bit more into the application of sending it out, and whatever the most popular programming language is going to be. Right now it's JavaScript. Don't boo me, people. Your boos mean nothing. I've seen what makes you cheer. I would say that one of the best things is whatever that's going to be, it's going to be going out towards everybody. And I think that's why you've seen a push for TensorFlow.js. It's very exciting and interesting, and the shareability of what's coming through is great as well.
Yeah, that key word is shareability, right? There's no point building the latest, greatest model that does amazing things if it only runs on your developer workstation or on your supercomputer. It's being able to get that model out into people's hands where they can use it and where they can do something useful, and where they can do something that hopefully changes the world, be it a lettuce drone, or be it some kind of gesture navigation or whatever. Without that deployability aspect, the AI can be limited in what's possible and what it can do, and the changes it can make. And JavaScript is one of the best ways of deploying models that's out there. I mean, there's not the only one. There's native deployment to Android and iOS. There's deployment to microcontrollers and that kind of thing. But when you think about how many browsers are out there, and it's just the opportunity for being able to deploy a model and get it literally into people's hands is second to none.
Absolutely. And actually, Medusha sent a question too.
Sure.
He says, do you happen to know a well-known app or product that is using TensorFlow.js? And I want to say, I'll start that off in saying I'm legally bound not to talk about one of them right now.
I like it already.
Under an NDA. So, but we did do one that I can talk a little bit about, where we're helping with a company do trying on makeup in the browser, which is a fantastic use of TensorFlow.js. Nobody wants to take a picture and then have it go to the server and then see what they look like with that particular makeup on. So we did get approval to talk about that one, but I did finish one back in January, but I'm not allowed to talk about that one. But yes, people are using TensorFlow.js.
Yeah, and something like the makeup try-on that you mentioned, the other nice thing about it, don't forget, is they don't need to install an app to do that.
Right. Yeah.
Right. They open the browser on their phone, everything in the browser, the camera, all of that kind of thing, the head tracking, all works. So it's not just try it on and get a picture, it's move your head around and that kind of stuff. To be able to do that is really
and
cool.
It's right there in the sales page, which I think is where people haven't really thought this through. Like, we've got interesting, I have tons of websites that do fun and interesting and exciting examples of stuff. But what happens is, when you're right there and the person's looking to hit purchase, they're looking at photos and they want to see, what does this package of makeup look like on them? I'm so old, I remember the mall. And you'd walk through the mall and there was the perfume and makeup section you couldn't breathe in, and there would be professionals there who will put the makeup on people to go ahead just to do that sale. And it was a long time taking process that people would do that. And this is funny. Now it's instantaneous. With the click of a button, you're now trying on 15 different styles of makeup.
Yeah. And and a lot of time when we go shopping today, they try to ask you to install an app, hey, sign up with your app to be able to get a 10% discount at the register, but they don't have cellular service in the store. It sounds like the beginning of your horror movie. But then when you can, if you can just do this kind of thing, it's really, really cool, like all in the browser. And I think that's really neat. And just to answer with a question as well, is that go to youtube.com/TensorFlow. And on there, Jason runs a thing called TensorFlow Show and Tell, where you can actually see a lot of great community stuff that's been done and a lot of apps out there using TensorFlow.js.
Perfect. Yeah, I think this has been amazing. Laurence, I'm always looking for an opportunity to hang out and chat with you. Hopefully, I'll see you at a conference. I'm speaking at a conference in April. I know yours, and I'll be speaking at Reactathon in the park in May. And you said you're speaking at a conference coming up soon?
Yeah, I'm speaking at a DesignCon conference in Santa Clara at the beginning of April.
Perfect.
So come see me.
I will. Yeah, we're going to run into each other at some point. Cooper,
Yep.
Can we get you back up here? I know we're getting close to an hour.
We could do this all day, though.
I know. I think we will. If you and I are ever speaking at the same place at the same time, that's just that's my day.
Bring
I apologize.
rations.
I'll buy you a teapot. It'll be great.
Sounds good.
And a chainsaw.
Okay, so as much as I love these conversations, I guess we on hard stop now. But yeah, you could feel free to continue the conversations another time, or maybe we can host you another time too. But thank you so much for joining us today and then sharing your thoughts, about the topic around TensorFlow.js and then web. So yeah, I would love to, thank once again, and then have a great rest of your day. And then I will just, conclude the session now.
Yeah. Well, just one thing before you conclude it. Go follow Laurence. Go follow Gant. We'll continue this chat at some point.
Perfect.
Sounds good. Thanks,
Bye,
everyone.
Bye. Alrighty, so I hope you enjoyed the session today, and then I would love to thank you all for joining us today, the Between the Brackets. So now I would like to kindly request from you to fill out the feedback survey that we have on the screen, or you can just see if you have the email coming from us, so that way you can just click on the link and then just fill out the form again, so we can improve the show along the way throughout the year. You can use our hashtag, actually, hashtag Between the Brackets, to share how this show was for you. So now we are going to actually have our next episode next month, April 22nd, with Roman and then Nilay from Google. Roman is a developer expert and Nilay is working for Flutter at Google. So they will talk about Flutter UIs, responsive and adaptive. So we are looking actually forward to seeing you next month. But if you have any questions, please email us at btb-team@google.com. And then till that time, please stay safe and then take care of yourselves. Thank you. Bye.